Welcome to Autodesk Virtual Academy, brought to you by your friends here at KETIV Technologies. I'm Nigel Umbayak, one of the customer success managers here at KETIV, and this morning I'm joined by one of my colleagues here, Alex Alvarez. Alex, how's it going?
Hey Nigel, pretty good, pretty good. How are you doing?
I'm doing great. Alex, for those of you who don't know, is one of the application engineers here on our team. Works primarily on the consulting side of the business, but on top of that, Alex is also our resident expert in all things manufacturing methods, whether they be subtractive or additive, which is the reason why Alex has joined us today for this webinar all about Fusion 360 and PowerMill. Since Alex is the resident expert on all that stuff, I'll let him explain what all of that means when he starts his presentation. But definitely, if anyone has any questions during Alex's presentation, go ahead and type those into the chat or questions panels that you have on your respective streaming item. And we'll go ahead and answer those when we get to that part of the webinar. Alex, do you have anything else to say before we get started?
No, I think that's perfect. Yeah, so I do want to start off by saying, so this is actually a continuation, more or less, of a previous webinar we did a couple weeks ago. We actually discussed the rebranding or the repackaging of Fusion 360 and PowerMill, right? So there was a little bit of confusion there. A lot of people were wondering, is PowerMill going to go into Fusion 360 or vice versa? It isn't, right? So just from the very beginning, I want to make sure that there isn't any confusion there. And a lot of people wanted to see workflows between the two softwares, right? Can they even work together? If they can, how are they supposed to work together? So this webinar is supposed to show you, or it's going to show you, some different techniques for how to use these two softwares. So let's go ahead and jump in. Again, just a few slides just to make sure everyone's on the same page here. If this is your first time working with Autodesk software, believe it or not, they actually don't just have software in terms of the design and engineering space. They focus on a large breadth of industries. They focus on entertainment, media and entertainment, right? So they have a lot of softwares under their umbrella. Again, what we're going to be focusing on today is going to be the manufacturing tools within what we call the Make portfolio. Make portfolio essentially is just a combination of packages that are a little bit more on the advanced side of the Autodesk software, the Autodesk spectrum, if you will. Those softwares range anything from CAM, additive, if you're doing inspection, composites, right? So you guys can kind of start seeing that it's a little bit more on the advanced side. And again, if you're doing anything on the advanced manufacturing, if you're working with robotics, or if you're working in the aerospace, automotive industry, chances are Autodesk has a software for you guys. Nice thing about that is that they don't just create the software and then give it out to the customers. They actually do have different facilities where they test the workflows, right? So what kind of company would they be if they're not testing the software that they're providing to their customers? So there are different facilities. One is actually in San Francisco. It's called Pure 9. They do anything from subtractive to some of the multiple technology. They test some of the different workflows that NetFab might use, or Power Inspect, right? So the other one is going to be in the UK. So if you guys are watching from out of the States, by all means, that's just another facility that that Autodesk has to start testing some of the software. Moving forward, again, just making sure that we know what this webinar is going to be about. It's going to be about primarily just two softwares within that Make portfolio. One of them being Autodesk Fusion 360. If you guys aren't as familiar with Autodesk Fusion 360, we are going to talk about it. We're going to go into the software. We're going to do a live demo. Really, the best way that I like to explain this is that it's really just an all-in-one platform for your everyday designer or engineer. Right, it does anything from design. It does renderings, animation, simulation, and then of course the bread and butter of it is going to be the manufacturing workspace that it has to offer. Again, what I want to make sure that everyone understands is that the workflow that I'm going to show today isn't the only workflow that you can do between these two softwares. This is just something that came to mind a couple of days ago. I decided to see what that would look like, and if it would make sense. Keep in mind that you can actually do the part that I'm about to show within Fusion 360 as well. So again, not to take anything away from either software here, but just keep in mind, be open-minded about the workflows, and then see how the the workflow that I'm going to show today can fit in your business. But again, with Fusion, it's just an all-in-one platform, right? The biggest thing being that it is a cloud-based software. One of the biggest things that it allows you to do, being that it is cloud-based, is that it's going to allow you to share much more seamlessly, right? So what are you sharing? You're going to be sharing data. You're going to be sharing PDFs, Word documents, whatever it may be. You can use Fusion 360 to collaborate much more seamlessly throughout your project. Now, the other software that we're going to be talking about is going to be Autodesk PowerMill. So PowerMill, if you guys aren't familiar with the software, it's really one of the Autodesk flagship CAM softwares. It does anything from advanced 5-axis milling. If you need to program robots, right? If you're going to be doing some sort of lights out machining, it can program robots. There's a large breadth of different machines that it can program as well. So if you want that fine-tuned control over the tool axis, or maybe you need to control some of the surfaces, or just have fine-tuned control over the tool path itself, PowerMill is going to be the tool for you guys. Another added benefit to PowerMill is that it actually does machine simulation as well, right? So especially running some of these more complicated 5-axis parts, one of the biggest worries when you're programming is my tool going to collide with the part or with the machine itself? Right. So again, with PowerMill, it does have machine simulation, and that's just another safety net, if you will, for your programmers that are going to be out on the shop floor. A common question I get is, can I use Fusion 360 for a certain workflow, for a certain part? Is there any overlap between the two softwares? There actually is a little bit of an overlap, and I feel like this chart here, again, if you've been watching our webinars religiously, you've probably seen me demonstrate this. There is a little bit of an overlap, right? So again, Fusion 360 can do anything from 2D milling all the way up to multi-axis milling, or what we like to call simple multi-axis milling, right? It doesn't have the same functionality that PowerMill has, but you can get by on some of those different tool paths. And then, of course, once you start getting into the more complicated multi-axis milling, if you want to have, like I mentioned, fine-tuned control over your tool axis, you can do all of those things within PowerMill, right? And then, of course, programming the robots down here as well. So this comes to the next slide. Well, what exactly happened to PowerMill and Fusion 360? Right. So again, this is just a couple slides that I took from the previous webinar that we did. There's actually a repackaging. Hopefully by now you guys are all familiar with the Fusion 360 and FeatureCam repackaging. Right. So Autodesk decided to take that same approach with the Power products. Right. So PowerMill, Power Inspect, Power Shape. Reason for that really is it just gives you more tools in your toolbox. Right. So the pricing, of course, we can always discuss pricing. I don't think I'm allowed to say what the price is on a live webinar. But if you want to learn about pricing, feel free to give us a call and we can discuss kind of what that looks like for both of these different packages. But essentially what you'll see now, if you go to the Autodesk website, and again, this is going to be for new subscribers. If you go to the Autodesk website and you're interested in PowerMill, you'll see that there's two different packages, right? So you'll see that there's an Autodesk Fusion 360 with PowerMill standard, and then there's going to be an ultimate version. Now, a common question I get is, well, what's included in either or? For the most part, really the biggest difference, obviously, you get PowerMill standard on the standard one, PowerMill ultimate on the ultimate one. But apart from that, you also get additive build extension, right? So if you guys are doing any sort of additive work, or maybe you guys are in the long run looking for something that has to do with 3D printing, you might want to start looking into the PowerMill Ultimate, right? If you're not touching PowerMill Ultimate at all, or if you're not really going to be using any sort of 3D printing technology, then again, maybe it's not necessary. Right. So again, just wanted to make sure everyone was on the same page here before we jumped forward. If you guys need help figuring out whether PowerMill Standard or PowerMill Ultimate is going to be the choice for you, like I said, just feel free to reach out. I'll give my contact info at the end of the webinar, and I'd be happy to talk about this with you. So with that said, again, just a quick and short here, PowerPoint. Let's go ahead and jump into Fusion first, just to discuss kind of some of the action items here. This is your first time in Fusion. This is where you're going to get. Again, this is the user interface. You'll start seeing here, Autodesk is making a lot of changes that they're actually starting to improve some of the user interface and kind of the user experience for some of their softwares. Reason being is because they actually want to start, I don't want to say making sure that they have the same commands, but they want to make sure that the user experience and the user, I guess the user feel for the software is similar across the different tools, right? So Autodesk is understanding that, hey, maybe users aren't just using Fusion 360, right? Maybe they have a workflow with Fusion and PowerMill, or Inventor and Fusion, or Inventor and PowerMill. What you'll start seeing is that some of the icons are going to start looking a little bit more modern. They're going to be getting modernized, if you will. And there's going to be some similarities between these different softwares. Now, again, not to say that the functionality from one software is going to get added into software B. It's just so that the feel of the two softwares is a little bit more familiar, and the users don't have to, spend a large amount of time trying to figure out what the workflow is there. So with Fusion 360, you recently actually got a facelift. And again, what I was saying is that it's an all-in-one platform. If you want to do your design work, you do your design work. You have your sketching tools, your 3D modeling tools. We're actually going to be using the surfacing tool a little bit here. So just a little foreshadowing. But once you're ready with the design work, what you can do is hit the drop down, and now you have different environments. Right. And again, generative design, this is again just another added benefit that you now get with the Fusion 360 and the PowerMill subscriptions. Right. And again, this is just one of those things where a lot of people still aren't as familiar with the technology. And this is just coming from me, the way that I'm seeing where some of the industry is heading. It is going to be some pretty powerful technology, right? So it's better to kind of start at least getting familiar with the technology and just seeing what it does. And then better to be sorry at the end and just kind of be catching up with the industry towards the end there. So again, with Fusion 360, you do get generative design, you get rendering, animation, simulation. You actually get a manufacturing workspace as well, right? And so again, that you have a couple of webinars on what the manufacturing workspace can do, kind of some of its limitations. And so again, today I do want to make sure that I cover at least some of those limitations and some of the differences as to what you can do in PowerMill and Fusion. As I stated in the beginning, if you want to share the project, or maybe you want to share additional information, again, you're not just limited to storing Fusion data in here, right? So you can store Word documents. I know I've actually stored PDFs in here. Maybe you have a quality report, right, that you want to share with someone, or maybe you have an Excel spreadsheet. You can share all of that inside of this data panel. And you can do it seamlessly, right? So again, you can invite multiple people to the project, granted that they have Fusion 360 as well. But again, you're not limited to just sending out a shared file, or maybe setting up a Dropbox, setting up a shared network, right? So everything is going to be up to date, and so everyone is going to be on the same page once they're a part of this project. What I also want to talk about too is that you're not just limited to Fusion 360 data in here. So Fusion does have any CAD capabilities. Essentially, what that means is if you're going to upload a part, right? So if we go to select files, click on the drop down, you have a pretty large variety of different parts that you can upload into Fusion, right? So if you're working with Pro E, maybe you're working with KETIV, right? So parasolids. So you have different options here to work with. The great thing about that is that, again, if you want to, maybe you want to, oops, sorry about that. Maybe you want to do a small change. Maybe there was a hole that didn't come in correctly, or maybe you want to do some work, additional work on that model. You don't need to send it back to the customer. You can do all of that work inside of Fusion 360 and continue off kind of from where they left off, right? So that's one of the things that I wanted to paint today. Is we got this part sent over, right? They actually did a great job putting it in the vise. It has our stock already. It's again perfect. Now let's go ahead and machine the part. Like I said, you can actually do this work inside of Fusion, right? So just to be clear on that, it's not like you can't do that. But the workflow that I want to go ahead and show today is, let's jump into PowerMill, right? How would it look like if I decided to do this part inside of this software? You can see that I already have a few tool paths laid out. If you guys are Fusion users and you're new to PowerMill, this is what PowerMill is going to look like once you jump in. All right, so a little bit more information than what we're probably used to, right? So again, you have different tabs, and like I said, this just goes to the point that I was making, that you have more control over your tool paths, right? So now it's not just select a boundary, place the tool path, and then try to modify it with the sketch or try to modify it with surfaces. You can actually start modifying the tool path with some of the different options that we see here. Right, so you're going to get that expert control. The workflow is not too complicated. Again, it's going to be a very linear workflow, if you will. So you're going to start off by creating your work planes. So where do you want your WCS to be at? Work planes are very similar to that in Fusion. So if you guys are familiar with tool orientation in Fusion, work planes are going to come pretty natural. Once you have your work planes created, you're going to want to set up your block. Right, so the actual piece of material that we're going to be cutting, you want to make sure you set up your tool database, right? Whether it's going to be local or whether it's going to be a network database, you do have the option to work off of that as well. And then once you have your tools created, the next part is going to be adding your tool paths, right? And that's kind of the point that I'm at here. You can always simulate this, right? So we can go ahead and say simulate from start. You can have the stock turned on if you wanted to. You can just run it by itself. So you have different options here, right? So if we turn on the stock just to see kind of what this looks like, let me go ahead and activate this one just so we can see the tool path. And then of course you have your control speeds up here. If you wanted it a little bit faster, a little bit slower, you can control it using your arrow keys as well. So just another added benefit there for fine-tuning the simulation, right? So very traditional toolpath. If you guys are coming from Fusion, or if maybe you're coming from a different CAM software, actually, what I'm using here is called vortex milling. Right? It's called adaptive in Fusion. It's probably called hypermill in some other softwares. Again, benefit of the vortex milling is that you're controlling the optimal load of the tool, right? So you can machine with a larger part of the flute length here. Instead of doing that traditional style toolpath where you're only machining with the bottom 50 thousandths, 60 thousandths, or even 100 thousandths of the tool, right? So now you can engage the entire material with more of the flutes here. We have an ID rough as well, right? So we'll go ahead and say simulate from start, and then we'll go ahead and play this as we're going. Again, this is a little bit more of your traditional toolpath, right? So again, it's kind of just offsetting as it's working its way out. But again, the point that I want to show here is this part was completely imported from Fusion, right? So I didn't have to recreate it in here. I didn't have to do any additional work. I just brought the part from Fusion. I finished it inside of Fusion, right? I modeled it, designed it, put the assembly together, and then I went ahead and export it out to PowerMill. Now, there are different ways to export out, and I'll make sure to talk about that here in just a bit. So you do want to be careful and aware of how to export out these models. Right. So again, traditional roughing toolpaths, you should all be pretty familiar with these. So now what I want to do is I want to start adding a little bit more of the finishing toolpaths. Right. So I roughed out the inside. I'm not going to program the entire part, but I just want to show a couple of features here for PowerMill. Right, so I programmed the entire part, or part of the part. Now what I want to focus on is going to be the inside bowl here. All right, so what can I do for that? I don't have a lot of material here, so I can go straight into a ball end mill. Again, so that tool is going to be here at the bottom. Right, I can activate it just to see what it looks like, see if it's maybe a little bit too large, maybe I need to scale down, whatever it may be. Right, so for us, I'm going to go straight into the toolpath. and we're going to be presented with this dialog box here. Now, nice thing about this, in my opinion, at least coming from Fusion, which was my original software, it actually does a pretty good job splitting up the toolpaths, right? So it tells you that there's a 3D area clearance, tells you that there's finishing toolpaths. If you're going to be doing feature machining, right? So maybe you were using Feature Cam in the past, and now you're kind of transitioning over to PowerMill, right? So you do have the option to do feature machining. You have drilling toolpaths. You have some more of the more advanced toolpaths down here as well, right? But point is that it actually does a really good job here of splitting up the different toolpaths. Not only that, again, you'll kind of see that for some of these, it'll give you a tooltip, right? So it'll tell you exactly kind of what this command is going to be doing, right? So for us, we're going to go ahead and we have different options here actually. So you can actually do the 3D offset finishing. You can do a constant Z finishing, radial finishing as well, right? So it kind of does a nice job here demonstrating kind of what that toolpath will look like. If you guys are using Fusion at the moment, take a look at that, right? So there's a rotary finishing toolpath as well, steep and shallow finishing toolpath here as well. For this part though, I think this feature, again, what we're trying to look for is a toolpath that's going to accentuate this feature nicely, right? And for me, I feel like the spiral finishing is going to do that for us, right? So let's go ahead and select that toolpath. Again, we have the ball end mill here active, so we're going to go ahead and run with that. All right, and so we're going to be presented with this dialog box. Again, a lot of information. You don't need to manipulate. You don't need to change every single setting that you see in here. But it is nice to go through it and just familiarize yourself with what each of these options is going to do, right? So again, kind of very similar to the workflow that we have here. So we have the work planes, we have the block, we have the tool. So now you don't need to worry about, okay, maybe some of the workflows changed. Now I need to relearn this new workflow. It's going to be very similar to kind of what we have up here at the top, right? And this really should just be a repeat of what you did up here, or it should have that information already at that point, right? So starting off with the tool, we make sure that we have the correct tool here selected. The machine tool. So again, we do, like I mentioned, machine verification or simulation. So you can set a specific machine in here. The next thing is going to be the limits, right? So where do you want to contain this toolpath to? You can create boundaries, so very similar to sketches, right? So what I'm going to do is I'm going to select this ID boundary, make sure that it's set to keep inside, right? And then you can start setting some of these Z limits as well, right? So what the Z limits is, and again, you'll start hearing me compare this a lot to Fusion. Reason why I do that is we have a lot of Autodesk Fusion 360 users here, so just making the point between the two softwares, right? So what does this setting translate over to that software? And if you're using PowerMill and you want to ever use Fusion at that point, now you at least know what the relation is between the two settings, right? So the Z limits is it's more or less it translates over to the heights tab, right? So what's the maximum that this tool is going to be machining at? What's the minimum? Again, for this one, I'm probably going to take off the minimum. For Z limits, again, you don't just have to guess here. You do have the option to select, right? So if you wanted to select a specific point, so let's say I knew that I wanted to stay at or above that point, right? It's a 11.8. I can go ahead and keep this down a little bit, so 11.75. Okay, so that was the limits. The next thing is going to be the actual spiral finishing toolpath settings in itself, right? So when you select on spiral finishing, you're going to get a few options. So what's going to be the center point, the radius, right? So it is working off of a radius. And again, anything that's blue here gives you the option to select, right? So if you need to select anything here, that's one of the ways that you can go about it. The thickness, right? So are you going to be leaving any material behind? For us, again, we'll say that this is a semi-finish, so we'll probably leave 20 thousandths. And then the step over, right? One thing that I want to point out here is, again, sometimes we want to use the step over based on the tool that we have. Very similar again to what we've been able to do in Fusion. If you right click on this, you do have the option to say edit expression. Right, so again, PowerMill starts introducing some of the same capabilities. This one goes a little bit more in depth, so there's probably a couple more things that you can control here. So if we click on edit expression, this is what it looks like, and you'll see that looks like I already have something in here. Right, so it looks like it's 25% of the tool diameter. So I'm gonna be okay with that. Close this out. Again, I don't want to make too many changes. I just want to see what the toolpath looks like. The spiral toolpath actually does a nice job here of giving you a preview. Right, so we can go ahead and say preview. And what it does is it's going to project, so it creates a projection of that toolpath on the XY plane, if you will. And what we're going to do is we're going to project these lines or this toolpath down onto the surfaces, right? So hopefully you can see kind of what's going to happen with some of these gaps here. All right, so we're going to go ahead and say calculate. And again, didn't want to spend too much time on the toolpath because again, take a look at that, right? So it's going to start bleeding down into the bottom. Now, this comes the part where I'm going to again reiterate, there's many different ways to go about this, right? So if you're using PowerMill, chances are you were using PowerShape or the PowerMill modeling, right? So you can do some of the surfacing on that tool as well, no problem. The workflow that I wanted to show today though is I have this part inside of Fusion, right? I created that part in here, meaning I have the sketch, I have everything already necessary in order to quickly come in here and create a surface, right? So what I can do is I can come back in here, I can go into my sketches and then see which sketch was the one that created that surface. And it looks like it's going to be this one here, right? So looks like they did a revolve for that. So what I can do is I can come back in, I can turn on the visibility for it. And again, whoever created the part, so not blaming anyone here, but looks like they did a few no-nos here, but that's okay. But anyways, what I was going to show is you can come back in, you can go into the surfacing tool, right? And what we can see is that there's actually a revolve profile. So surfacing tools and solid tools, you'll start seeing some similarities between the both. Obviously, biggest difference is that with the surfacing tools, you're going to create a zero thickness surface out of this. Another benefit to this is that you can actually create a surface or a revolve even though it's not a closed profile, right? So we can extrude specific profiles even though they're not fully closed. If you're working with the solids, obviously you need some sort of a closed profile in order to revolve or extrude, right? So inside of the surfacing tool, you don't need a closed profile to do that. So what I would do here is I would come into the revolve tool. Again, we have the sketch visible, so it automatically knows that there's a profile that I want to revolve. If it's only a few sketches that I want to select, you want to be careful with the chaining option here. Otherwise, it's going to want to chain the entire sketch. And for us, it's really just going to be as easy as selecting the sketch, right? So maybe I want just this part here, right? We're going to go ahead and select the axis. We'll say that this is the axis here. We get a warning because our bodies are turned off, right? So it's going to go 360. I'm going to go ahead and say, okay. We'll turn our bodies back on and you can see kind of what happens there. Right, so again, you can do this in PowerShape, no problem, or you can do this in a different modeling tool, or if you're using PowerMill modeling. You can probably get by maybe modifying the toolpath. But again, we created this part in Fusion. If we didn't create it in Fusion, we can quickly modify it if we were in the tool. Right, so again, point being is that you can now quickly make these modifications, and now what we can do is we can come back into our tool, and now we can start exporting this model out. Now, let me pause here for a second because I did skip an important step. When I imported this part, right? So when I first imported this part, let me see if it shows me the path here. Yeah. right? So there's a specific path that this part is currently located in, right? So it looks like it's going to be my OneDrive. The biggest thing here is making sure that the paths match, right? So if I'm going to be exporting this part out, I want to make sure that the path that I exported out to matches. Not only that, I also want to make sure that the name is also going to match, right? Because if it doesn't match, then it's going to see it as a different part and it's no longer going to work, right? So you have to make sure that the name is exactly the same. So again, a couple workarounds for that. That's something that we can talk about at a later time. But what I'm going to do here is I'm going to go into the file. I'm going to go ahead and say export. I'm going to remove version 2. For those of you Fusion users, you can export locally, by the way, right? So if you guys weren't aware of that, you definitely can, right? So you can export it as different file types as well. So it doesn't have to be Inventor or Fusion. It can be SMT, it can be step files, right? So I'll keep it as a step since that's what I exported it originally. And then my path here is already created, right? So it's already set correctly. So I'm going to go ahead and say export. Do you want to replace it? I'll go ahead and say yes. So wait for the confirmation, and now I can go back into PowerMill. And again, this is where you have to have standards, right? As a company, if you did make a change or if a change did go through, you want to make sure that there's a procedure for your employees to kind of follow, right? Otherwise, again, it's not going to work. So from the very beginning, it's not going to tell you anything. It's not going to throw up a warning message. You as a programmer have to know that there's some sort of a change there, right? So for us, I'm going to go ahead and right click, and we do have this re-import model. Notice that you can export the model as well, right? So maybe you want to export this out of Fusion, bring it back in, you definitely can. So there's a workflow for that as well. For us, we're going to go ahead and say re-import model. Go ahead and select our model here. Give it a couple seconds. And again, what this is going to import is really just surfaces, right? So if you ever need to hide that surface again, you can just blank it. So you're not just limited to having that surface and then being, having that surface there for the entirety. You can blank that surface if you want to. We get a warning saying that the import has detected new components, right? So that's pretty good at least. So it at least detected that there was something new done to the model. So I'm going to go ahead and say, okay, cancel this, and there's our surface, right? So again, we no longer have to go into the PowerMill modeling. We can do that again much more quickly using Fusion 360 with that toolpath. Right, so again, I'm going to go ahead and delete this one. You should be able to actually just regenerate it, right? But what I wanted to show is I actually wanted to show a different toolpath for this one. I'm not sure how visible it was for you guys, but the only bad thing that I didn't really like about the spiral is that it leaves inconsistencies in the surface, right? So the cusps are going to be inconsistent. What I mean by that is that it's not going to have a constant cusp as it's working its way down. A toolpath that I will probably prefer for this one might be the constant Z finishing. All right, so I'm going to go with the constant Z finishing. I'm going to say okay. Again, we still have that same ball end mill active. I can call this bull semi. Going through some of these options again, right? Making sure that I have everything correct. So we have the machine tool, we have the limit, ID boundary, we're going to say keep inside from 11.75. That's good. Constant Z finishing, right? So we're still leaving 20 thousandths of material here. Right, what's the minimum step down going to be? I'm going to go ahead and keep it down probably 80 thousandths for now. Right, and that's all I'm going to do for this one. Right, so again, don't want to change too many settings. I kind of want to take a look at what this generates first. So I'm going to go ahead and calculate this toolpath. And again, the limit that I set is preventing it from machining up here at the top, right? So I went down 100 thousandths below kind of the start point here. So reason for that is maybe we want to use a different toolpath for that, right? Maybe there's a steep and shallow that I can use, or maybe there's just a different toolpath that I want to use on the surface. So I'll go ahead and prevent it from doing that, right? And so if we simulate this, so I'm just going to go ahead and simulate it without the stock to kind of speed up. We're getting kind of crunched on time here. Right, so it's going to start from the top. It's exactly what I want. It's going to work its way down. It's perfect. And then it's going to start machining this little A here, right? But again, for me, not a big deal. I can go ahead and again, just stop it here, machine a different portion, or use a different toolpath for this. But what I want to do, so I like the way that it started on top. The only thing that I didn't like is that it's machining the A. And the other thing that I want to do is take advantage of our 5-axis machine, right? So we have a Mazak machine here. Again, it's going to be 5-axis. What I want to do is I want to tilt the part slightly so that it changes the axis rotation, and then I'm able to machine a little bit more with the side of the tool, right? As I'm at the top here, it was doing a pretty good job of machining with the side. As it starts getting to the bottom, right, it's machining with the bottom of the tool. So let's go ahead and take advantage of that, and then make that change relatively quickly, right? So we'll go back once again into the settings, and again we're going to tighten up the step down a little bit more. So we'll go back into our constant Z finishing. Probably say 20 thousandths, right? And then the next change that I want to make is going to be the tool axis. Right, so let me go ahead and position this a little bit easier here. All right, so the tool axis right now is going to be vertical, right? And that's great. What I want to do is instead use a from point option, right? So by using a from point option, you can start seeing that now it gives you X, Y, Z coordinates, right? So where do you want that point, that reference point, to always be tilted, right? So where do you want that tool axis to be tilted towards, right? What's the point or the position of this? Again, very similar to kind of what we've done in the past. You can select the position form, if you will. Select the point roughly around where you want it, and then it's going to give you a specific value for that, right? So I already did that just for sake of time. I believe it's going to be somewhere around 12.5. You can use the tool axis limits, right? So if you want to ensure that it doesn't do any over travel, or that you don't get any sort of issues as it's rotating around the Z axis, that's something that you can also set, right? So again, a lot of flexibility with this toolpath. So what I'm going to do is I'm going to leave it at 12.5. I'm going to go ahead and calculate this. Right, so a little bit better step over there, or step down. And now what I wanted to show is, again, this recently got introduced inside of Fusion 360, but very similar in here. Select the toolpaths you don't want, and then delete the selected toolpath segment. Right, and so now we can go ahead and simulate this once more. So simulate from start. Go ahead and play it. Probably look better if I turn the machine on. And there you can see how it rotates. And again, it's passing through that point that I had set. Right, so again, I probably should have added a tool holder here to make it a little bit more realistic. And again, something that you can control is also those little tiny lifts that you see there, right? So you can have it be a continuous toolpath as well. That way you don't get any witness marks or any little cusp left behind. But again, that's what I wanted to show. Again, the workflow here that I just covered, just to do a quick recap. Designed the part inside of Fusion. We have all the sketches, all the features inside of Fusion 360. So why not take advantage of that, and then and then machine, take advantage of that, and then use that to modify the features, and then that way it gives us a much better toolpath here, right? Instead of going through different methods or going about it differently. So that's what I wanted to show. Again, guys, hopefully you picked up something from this. Like I wanted to mention, this isn't the only workflow that you can see here. There's many different ways that you can go about this. So you can do fixtures, you can do your soft draws, export them out to Fusion, re-import them back, right? So there's many different workflows that you guys can take. If you guys have any questions, this would be a perfect time. Let me go ahead and go back into my PowerPoint. Okay, so here's my email. Like I said, feel free to reach out to me if there's any questions. I have experience in PowerMill, FeatureCam, and VenderCam. So if there's any specific workflow that you're having issues with, like I said, feel free to reach out. Nigel, is there any questions coming on your end?
Let's see. Do you mind going over some of like the training opportunities that we have? There's a couple of people asking about like iLogic training and stuff.
Yeah, absolutely. Yeah. So we do, and it really depends on what you're looking for, right? Are you looking for just a standard introduction to iLogic? We do those. If maybe you have a little bit of iLogic experience and maybe you're using it within the company and maybe you want it to be a little bit more custom, we also tailor those trainings based off your needs, right? So we can do it. It's anywhere, I believe, anywhere from 2 to 3 day trainings. Obviously, if you wanted to be custom, we can be a little bit more, and we cover anything from working with parts, right? Working with different configurations, working with assemblies, and then even working with external data such as Excel spreadsheets as well.
Yep, awesome. Yeah, there's a ton of videos. If you want specific training for your organization, like Alex mentioned, we do that too. So just let us know. I just posted the link to the other webinar in the chat. So if you want to understand better the packaging of the products and some of the changes they've made from a formal standpoint to like the licensing and whatnot, that webinar went over a lot of that information.
Mm-hmm.
Let me double check on more questions. I think that's just about everything that we have for questions.
No, I think that's going to be it. Like I said, hopefully you guys picked up a thing or two. Obviously, there's going to be more workflows that we come out with. This is so the repackaging just took place a couple, I want to say last month, I think. So hopefully Autodesk starts sharing a little bit more on the repackaging and a little bit more on kind of where they're heading with the repackaging there.
Absolutely. Thank you again, Alex, for joining us this morning for this webinar, and everyone who attended today, thank you for joining us. We'll see you all next week.
Yep.
We're going to be going over some Design Accelerator in Inventor, so really excited for that. We'll see you soon. Thanks again, Alex.
Awesome. Yep. Thanks, guys.
Bye-bye.